Hello and welcome to the 7th lesson in unit number 2. We're looking at real-world applications for the quadratic functions. So what I want you to be able to do is, I want you to be able to determine what the question's asking for and then do what's appropriate. So either factor, complete the square, or do a substitution in order to find the right answer. Okay, so that is our goal for this. We're looking at word problems. So what I've got down here is a couple things, sort of a cheat sheet on what we need to look for when something's being asked. So, what can we find and how do we find it? If the question wants x-intercepts, that means that we need to set function equal to 0, and solve. So that means we're going to have to factor if possible. Okay? So the question will be, when does it land? When does it land? So we're looking at when does it reach that x-axis. So when does it reach x-axis? All right, x-axis. Okay, y-intercept, hopefully by now, as soon as you see y-intercept, you should be thinking initial value. Okay, initial value, no matter what, we let x equal 0 and solve for y. Doesn't matter what form. Oh, so now I'm writing down the word form. Okay, solve for y. Okay, every time. So it doesn't matter whether it's in factored form, doesn't matter whether it's in standard form, it won't matter. Just plug x equals 0 into it and you will get your answer. Vertex, we need to complete the square. Complete the square. Oops. S-Q-U-A-R-E, complete the square. And this one's pretty easy to know when that happens because we have to use the word maximum or minimum in the question. So what is the maximum value? So for a parabola, this is the highest point of the maximum value. This is the minimum value or the lowest possible value. So those are the two key words. As soon as you see max or minimum, you know you're going to have to complete the square. Initial value, okay, just did it right above. It's your y-intercept. Not going to add anything to that because it's kind of cyclical or sorry, it's the same thing all over again. And finally, your axis of symmetry. When are you going to have to find your axis of symmetry? Well, if it says, halfway is the only time I can really think of it, what application. And you can find the axis of symmetry from vertex form, obviously, or from factored form. All right. So those are just some general guidelines as to what you'll be asked and how to solve each one. All right. So it is using all the skills we've gotten up to this point. So let's take a look and see two examples on what I expect you to be able to do. First example. It says that a model submarine, so this is just a little guy, we put it in a swimming pool. Data collected by these crazy students uses the floor of the pool as the reference point. So the floor of the pool is your reference point. The submarine ascends, so that means it was at the bottom. It's coming back to the surface, and that's the function right there that they determined. So they use software to come up with that equation. D of t is the depth in centimeters, and t is time. Okay, t is our time in seconds. So we want to answer the following. What is the initial depth of the submarine? So keyword here, initial. Okay, so initial depth. If you look back at your cheat sheet, this is your y-intercept. How do we find the y-intercept? We let x equals 0. So that's kind of what's going on in my head. Initial depth, that's my y-intercept. I gotta let x equal 0. And in this case, it's gonna be t in this case. So for A, I'm going to rewrite my equation. Negative 0.5 t squared plus 10t minus 50. I want to find the initial depth. Initial depth occurs when time is 0, so I'm using the function notation. So that tells me everywhere there's a t, I'm going to replace it with a 0. Negative 0.5, 0 squared plus 10 times 0 minus 50. Simplifying that, multiplying by 0 makes math easy. So negative 50 centimeters. So therefore, the initial depth was 50 centimeters. All right. So that negative just indicates that it is under the reference point. So it's below the surface, 50 centimeters below. All right. B part. How long will it take the submarine to reach the surface? So remember, we're talking about the submarine's in a pool. All right, here's my water. Here's my sub. Put a sail on it. There we go. Okay. Now, it's a quadratic, so it means it's following a parabolic arc. So it goes to the surface in a parabolic arc. This is going to be the highest possible point the sub will get because subs can't fly, for those that aren't familiar with submarines. So this is going to be what we call our vertex. All right. So we need to find the vertex for this question. So in order to find the vertex, we will need to complete the square. So d of t equals negative 0.5 t squared plus 10t minus 50. Again, completing the square, let's factor out negative 0.5 from the first two terms, leaving me with t squared. Took out a negative, so it'll change the sign. And remember, we leave that last one alone. Negative 0.5 t squared minus 10t. We divide by 2, so that would be 5. Square it, be plus 25. To keep balance, I have to subtract 25 minus 50. Those first three terms create our perfect square. So negative 0.5 bracket t minus 5 squared. That negative 0.5 has to multiply the 25. So that means it's going to be positive 12.5 minus 50. Final answer, negative 0.5 t minus 5 squared. That'll be minus 12.5. All right. So the question was how long? Well, we know that our t value is time. Okay, so t is our time. Right there, it says it in the question. So that's when the vertex will occur. So our answer to this question is, therefore, after 5 seconds, the sub will surface. All right. So then we're on to C, the final question. When is the depth 35 centimeters? So what they're telling us here is we want to know the time in which this is 35 centimeters. Okay. So we do our substitution into the equation. So 35 will equal negative 0.5 t squared plus 10t minus 50. We can only solve equations that are equal to 0. So I'm going to subtract 35 from both sides. So I get 0 equals negative 0.5 t squared plus 10t. And that gives me negative 85. Now, the one thing I realized, I made a bit of a mistake here. Not a big change for us, but it said, what is the depth at 35 centimeters? When is the depth 35? This should actually be negative 35 centimeters because negative, we're looking at it being under the water, which means that I need to add 35 to both sides. Sorry about that. So I got to add 35 because it should have been negative 35 because it was negative 35 deep. So adding 35 to that will give us of 15 instead of the 85. Now at this point I'm looking at it and I'm saying to myself, I could try to factor it, but in all honesty, myself as a teacher, I'm going to go ahead, I'm going to use quadratic formula. So this is going back to Unit 1, and let's use quadratic formula in this case, just because it'll probably be a little bit more efficient if this doesn't work out evenly, okay? So t would equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 10, that's my b value. So just as a refresher from the first unit, a, b, and c, plus or minus 10 squared minus 4 times negative 0.5 times negative 15. Divide that by 2 times negative 0.5. So negative 10 plus or minus. Inside the square root sign, I've already done the calculation. It's 70, so square root of 70 over negative 1. So running that through our calculator, we're going to get negative 10 plus square root of 70 divided by negative 1. So it'll be 1.6 seconds. Or there's always two answers. Negative 10 minus, I shouldn't say there's always two answers, but there's potentially two answers, or 18 seconds. Now, you have to reevaluate, are they both valid answers? We're measuring time. They're both positive, so that means both answers are correct. And the reason for that, remember, the sub, if I draw my pool again, here's the water, the sub goes up, the sub comes down, so at 35 centimeters, it happens twice. So therefore, the sub will be 35 centimeters deep at 1.6 seconds and 18 seconds. All right. Now keep in mind, not every question is going to involve all of this. Some questions, I've made sure I put a whole bunch into this so I can reduce the number of word problems. So I have one more to do. I'm going to put it into the next video because I'm going to have to use the next video anyway. So I'll see you in a second.